Hi everyone, welcome again to Solid State Foundations. Today's topic is solid state characterization of active ingredients. We're going to talk about what it involves, why it is essential, and when it should happen. Let's start. Solid state characterization tells us how the material behaves physically and thermally. In other words, its crystallinity, phase purity, morphology, particle size, and stability under different conditions. And why is it important? Because these properties determine how your active ingredient performs, from manufacturability and dissolution to long-term stability. But there's more. Robust solid-state data supports your IP strategy, helping you define and defend your unique form, and it guides formulation design, ensuring consistency and reliability from early studies to scale-ups. And when is the appropriate moment to do it? Characterization should start in late discovery or early development, once there is sufficient material. To have data that gives you the full picture of your solid form, which is essential for confident decision-making, you will need at least an XRPD to confirm crystalline form and phase purity, a DSE and TGA to assess thermal behavior and solvating nature of the solid form, a DBS to evaluate moisture uptake, microscopy and particle size analysis to assess morphology and particle size, and finally, stability studies at 40 degrees 75% relative humidity to predict shelf life. In conclusion, solid-state characterization at the very beginning of development can save you from major headaches later on. Specifically, it will allow you to confirm your ingredient is not a mixture of forms, understand the solid form landscape and potential polymorphic conversions, strengthen your IP protection, and also ensure batch-to-batch consistency. I hope you've enjoyed this new chapter of Solid State Foundations. See you next month!